Hello. We are going to look at the review for the linear functions test. This is the third test in the first 9 weeks. So this is test number 3. All right, I'm going to try to do a couple of different problems, trying to get one of each type for y'all. So let's look at number 2. It says, how will the graph of the line f at x equals 7x minus 8 change if 7 is replaced with the number 9? So let's go look where 7 is. Okay, so the 7 right here is in front of the x. So if the 7 is in front of the x, does that mean it's the slope or does that mean it's the y-intercept? That's right, it's the slope. So the slope is going to change from 7 to 9. All right, so let's think about that for a second and let's do a little bit of exploration here. If I have a slope, let's see, what's my y-intercept? My y-intercept's negative 8. So if I'm down here at negative 8 and I go up 7 and over 1. Okay, so this is a slope of 7. Okay, if I change that to a 9, so instead of going up 7 and over 1, I'm going to go up 9 and over 1. And I'm going to graph that new line. Okay, so how does the line change? Not exactly the same. They're close to the same. They have the same y-intercept. But how steep the line is changing. So is it steeper with the 9 or is it steeper with the 7? That's right, it's steeper with the 9. Okay, so let's see, what are we going to write here? The line will become, so if we change the 7 to a 9, so if this right here becomes a 9, so that'll be 9x minus 8, the line will become steeper. Okay, so let's see. I'm going to leave questions 1 for y'all to try, 3 for y'all to try. Okay, so let's look at 4. All right, so the function 1/2 x plus 3 is shown below. So this is the graph. We start at 3 and we go up 1 over 2, up 1 over 2. All right, so let's see. It says, which of the following represents the line that has been translated down 5 units? So I'm going to take this entire line and I'm going to shift it down 1, 2, 3, 4, 5. I'm going to take this one and go down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The whole thing goes down 5. And we draw our new graph. Okay, so let's see what we've got here. It's the same slope. So I need to have the slopes that are 1/2. So it can't be B and it can't be A because the slope didn't change. Right? The lines are parallel. Okay, so let's see. Is my y-intercept at negative 2 or is my y-intercept at negative 5? So let's look and see. It looks like this is negative 1, 2. So my y-intercept is going to be at 2. So there is the graph that has been shifted down 5. Now wait a minute. It says translated down 5. Okay, hold on a second. So we start at 3. And then I go down 5. So 3 minus 5 is going to give me negative 2. Okay, perfect. Check. Awesome. That's the right answer. Okay, let's look at number 5. Now, I'm not going to do all of these, but I do want to do one of them. Let's go ahead and, first of all, let's talk about the m, the rate of change, and the slope. Those are all the same thing. They are all equivalent items. When they're asking us to find the m, the rate of change, or the slope, what they're asking us to find is the rise over the run. Okay, so let's see. Let's go ahead and do number 5b right in the middle. So they give me 1 point. Okay, that's good. Now, just to review, this point right here is negative 3, 4. The x value is negative 3. The y value is 4. Let's go find another point. The x value here is 0. The y value is 2. So if I'm going to find the rate of change, I need to figure out my rise and my run. So this rise, I went down 2, and the run, I went over 3. Now we always write the rise on top and we write the run on the bottom. So the rise was negative 2 and I ran positive 3. So that makes my rate of change negative 2 over 3. The y-intercept is the point where it crosses the y-axis. So the y-intercept is where we cross the y-axis right here. Oh, I did that in yellow already. I want to do a different color. Let's say we'll do green. There we go. There is my y-intercept. So there's my y-intercept. And let's write down the number. It crosses the y-axis at 2. And I erased my slope. There should be a 3 right here. Now your equation always is in the form y equals mx plus b. That's slope-intercept form. The m in front of the x is your rate of change. The y-intercept is your b. So we're going to write the equation. The y is part of the equation. The equal sign is part of the equation. The m is going to get replaced with negative 2 over 3. The x is part of the equation. The b is replaced with 2. So my equation is negative 2/3 x plus 2. Okay, let's look. I'm going to leave 5a and 5c for you guys to do. Let's look at, I guess it doesn't really matter. We'll do 6a. Okay, so we've got this little bubble here. It says what does equivalent mean? So we're going to talk about that in a second. All right, let's look at this equation. In order to graph this equation, we're going to get, wait a second, let me read the directions. Okay, yeah, it wants me to get this in slope-intercept form. So to get this equation in slope-intercept form, that means we need to get y by itself. So let me write that down. Get the y by itself. All right, so if I want to get the y variable by itself, that means I need to move this 2x to the other side of the equation. So we've got 3y is going to stay there, is equal to, we've got 12. To move the 2x over, I'm going to subtract 2x to both sides. Now, I can't actually subtract the 12 and the 2 because they're not like terms. So it just stays 12 minus 2x. All right, now I need to divide by 3 to get the y by itself. If I divide 3y by 3, I have to divide the 12 by 3, and I have to divide the 2 by 3. So that's going to give me, let's see, that's going to be y equals 12 divided by 3 is 4. I can't actually divide 2 and 3, so I'm just going to leave it, minus 2/3 x. Now the equation is by itself, so that's going to be 4 minus 2/3 x. All right, now we need to graph this. So the y-intercept is the number that does not have the x on it, so the number that's by itself. So this is my y-intercept. So that's a positive 4, so I'm going to start up here at positive 4. And then the number that's in front of x is my slope. So my slope is negative 2/3. That means I'm going to go down 2 and right 3. So let's see, we're going to go down 2 and right 1, 2, 3. Down 2 and right 3. And then we just connect the line. Okay, so let's go back to this question in the beginning. It says, what does equivalent mean? Equivalent means that they're the same thing. So equivalent means the same. They are the same. So what I mean by that, let me erase this here. Here we go. Let's look at what we started with. We started with 2x plus 3y is equal to 12. And we solved, and we got that was equal, y was equal to 4 minus 2/3 x. These two equations are what we call equivalent fractions. Or sorry, that's not right. Equivalent equations. These are equivalent equations. It just means that they are the same. This is standard form of an equation. I think we're going to get to the name later. You don't need to know that it's called standard form. Anyway, ignore me. And this is slope-intercept form. That one you do need to know because that's the one we're talking about today. Slope intercept form. Okay, I'm going to leave 6b for you guys to try on your own. Here we go. Let's look at numbers. Let's see, 7. We already did kind of a problem like 7. Let's look at number 8. So number 8 is already having the y value by itself. So this y is already by itself, which means because y is by itself, this is already in slope, intercept form. Slope-intercept form, the number that's in front of the x is my slope. So the number that's in front of the x is -2. The number that's not in front of the x is the number that's by itself. That's my y-intercept. So that's going to be -3. So I'm going to start the graph off at -3 on the y-axis. Whoops. So I'm going to come down here. Let's see. Y is -3. So I'm going to put a point at the y-intercept of -3. And then the slope of -2. Remember, -2 can be divided by 1 and still be -2. So this is my rise and this is my run. That means we're going to go down 2 and we're going to go to the right 1. So I'm going down 2 and right 1. Well, I'm out of real estate. I don't have any more space. So let's talk about the opposite. The opposite of going down 2 is I could go up 2. The opposite of going right 1 is I could go left 1. So let's go up 2 and left 1. You can continue the line this way. Up 2 and left 1. And we are going to connect the dots. All right, here we go. Let's see what we've got. I am going to leave number 9 for you guys to try. I'm going to leave number 7 for y'all to try. And let's see. Let's look at, I'm going to leave 10 for you to try. Let's look at number 11. Okay, it says graph the table of values and write the function. So let's go ahead and graph these. All right, here we go. I've got -2, 1 is a point on the graph, so let's put that on there. And let's see, I've got -1, 3. I've got 0, 5. 1, 7 would be way up here. So let's look at the pattern. The pattern, we're going to go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. I'm going up 2 and over 1. So the change in y over the change in x. Up 2 over 1 is equal to 2. So that is my slope. All right, now let's go look and see where we cross the y-axis. So when I connect these points, right? So all of these points get connected. Where does the graph cross? Oops, that's not what I meant to do. Where does the graph cross the y-axis? Well, I kind of covered it up. Can you guys see what it is? Let's see. 1, 2, 3, 4, 5. Oh, there we go. And look right here. Isn't the x value of 0 give me a y value of 5? Isn't that the y-intercept? And that's what we see right here is that we've got a y-intercept value of 5. All right, well, if we look back at the equation is in the form y equals mx plus b. The number that's in front of the x is my slope. Well, we know that. The number in front of the x is the 2. The number that's by itself is my y-intercept. We know that too. That's the 5. So we can write this equation. F at x is just a fancy way to say y equals. It means the same thing. So f at x equals m was 2. We write the x. Plus the y-intercept was 5. So we write 5. Okay, here we go. Let's look at 12. And there's 2 of these, so that's perfect. I'll do 1. You guys can do 1. Let's see. Write the table, or the table represents some points on the graph of a linear function. Write a function to represent this relationship. Okay, so if we're going to write a function, right, we need y equals mx plus b. I'm going to zoom in so I don't have to write so big. Okay. Here we go. So this means that I need the slope and I need the y-intercept. I need to figure out what the slope is and I need to figure out what the y-intercept is. Okay, so let's see. All right, so from 12 to 17, how are we changing? That's right, we're going down 5. From -8 to -4, how are we changing? That's right, we're going up 4. So my slope is the change in y over the change in x. So the change in y is -5, the change in x is 4, so my slope is -5 over 4. And we're just going to plug that right in there for that m right there. Okay, the y-intercept is a little different. The y-intercept is when the x value is 0, and then we've got some number. So if we continued this pattern right here, notice how I have an empty spot? If I added 4, -4 plus 4 is going to give me 0. Okay, well, that's good. And then, let's see, we've got 0 to 8. Well, that's plus 8. If we continue the pattern, isn't there going to be a 4 in the middle there? 4 and then 8. All right, so let's come over here. If we continue this pattern, let's see, 12 minus 5 is going to give me 7. And then 7 minus 5 is going to be 2. And then 2 minus 5 is going to be -3, which is what we have there. Okay, so that works. So if we continue this pattern over and over again, it works. Well, again, the y-intercept is when the x is 0. Do we see an x value over here that's 0? I wrote it in orange. Now I can't see it. Let me go over it in black. Okay, there we go. Well, the x value is 0. Okay, so let's see what that extends to. What's the y value when the x is 0? 7. So my y-intercept, let me write this down, my y-intercept is 0, 7. So the b value is 7. Okay, so now let's plug that into the formula. The function's going to be y equals m is -5 over 4x, and then b is plus 7. Okay, so I'll leave the other table for y'all to try. All right, let's see. I'm going to leave 17 for y'all to try. Let's see. I'm going to leave 15 for y'all to try. Okay, so let me do 14 and 16. Okay, so let's see. 14, Jerome wants to go to the carnival. The wristbands for entry into the carnival cost $34.50. But each game charges $1.50 to play while you're inside the park. What linear function models the total cost, P, for the day at the carnival if G games are played? Okay, so let's think about this for a second. There's two things that we've got going on here. Okay, so let's see what those two things are. We are going to get P, which they say is the total cost. And then we have G, which is the number of games played. Okay, so if I'm going to the carnival, does my cost depend on how many games I play, or does the games I play depend on what the cost is? Well, they tell me what the cost is, so I know how much it's going to cost. All I can decide is how many games I play. So that means that the total cost is going to depend on the number of games. So P has to equal something with a G in it. Okay, so let's see. We can get rid of two equations because they're not P equals. This one says G equals, this one says G equals. The dependent variable's in the wrong place. So we can't have G equals, it has to be P equals because the cost is going to depend on the number of games. Okay, so let's see. If that's true, what are our options? All right, let's look and see. How many times am I going to pay this $34.50? Do I pay that every game that I play, or do I pay it one time? That's right, we pay this one time. So we pay this $34.50 one time. And then if I want to play additional games, I'm going to add $1.50 for each game that I play. That's where the G comes in, so I'm going to put the G next to the $1.50. So which one says that? Which one has the $1.50 next to the G and the $34.50 by itself? You guys are right. It's going to be B. All right, and then let's look at 16. Kim has determined that when she reads at a rate of 8 pages per minute, the relationship between the number of pages she reads, P, and the time that she spends reading, T, is described by the relationship P equals 8T. Which statement is true? Ooh, okay, so spoiler alert, I forgot to change that. On the test, this is going to be multiple choice. So let's look at the statement that we need to look for. They tell me in here what my variables stand for, so go look for that on the test. P stands for the number of pages that she reads. So one of these should be the number of pages that she reads. Let's see, T stands for the time that she's reading. So, does the number of pages depend on the time, or does the time depend on the number of pages? Well, it helps us out. Doesn't it have P right here? And doesn't it say that P has to equal the 8 times the time that she reads? Okay, so let's write this down. Here we go. So the number of pages that she reads depends on what is we looking at? Time is minutes. So this would be the number of minutes. And that should make sense, because if we read for more time, then I'm going to have more pages read. If I read for less time, I'm going to read less pages. The number of pages that I read is going to depend on how much time I've spent reading. And I'm going to let you all try number 17 on your own. I will go over that tomorrow before the test. Thanks, guys. Have a great day, and come see me if you have any questions.